Hello. This video will be on one example, or maybe two, of Euclid's division in Gaussian integers, and I'll put in maybe a sequence of such divisions together, computing the greatest common divisor of Gaussian integers. So that is really an illustration on a concrete example. Well, yeah, let's aim at computing the greatest common divisor of two Gaussian integers, say 1 minus 5i and 1 minus 3i. And the first step in computing this GCD is, well, divide the larger by the smaller. So the measure of largeness for Gaussian integers is norm, which is a squared absolute value, squared distance, and that is just the sum of squares. So here we have 1 squared and 5 squared together, which is 26. Here we have 1 and 9, which is 10, that is larger. So we should really aim at writing 1 minus 5i as 1 minus 3i times some Gaussian integer plus some other Gaussian integer, and this remainder, this second Gaussian integer, should be in our measure less than what we divide by. So the practical way of obtaining such R, it's not going to be unique, but it's going to be always reachable, is to compute a Gaussian number. So just a complex number with this time rational coefficients. So I should divide by negative by what I divide. So I'm just honestly dividing in the field of rational Gaussian numbers, and to do that the procedure is to multiply by conjugates of the denominator, both the numerator and the denominator. So I'll have 1 plus 3i appearing as factors upstairs and downstairs. And downstairs, well, the whole design is to make downstairs rational or real in general, and that will be just the squared norm, so that will be just that 10. And upstairs, whatever happens, happens, and that is in our case, so the real part of the product will be 1, and then with negative sign, the product of the two, which is negative 15, so 1 plus negative 15 will be positive 16, and then the imaginary part will be the product of negative 5 and 3, which is negative 15, sorry, negative 5 and 1, which is negative 5, and on top of that will be just 3. So that will be negative 2 copies of I. And simplifying, we could just cancel out 2 everywhere, so we'll have 8, and then negative 2, just negative I over 5. So the key trick here is to look at the closest Gaussian integer to this Gaussian number. So that is with rational coefficients. That is a complex number with both rational, real and imaginary part. We can look at the closest, well, an absolute value in each of these parts Gaussian integer. So that's what we will then take as our Q. And then the closest to 8 over 5, well, will be 2. And the closest to negative 1 over 5 will be 0. So there will be no i's in this Gaussian integer. That is still to be considered as a Gaussian integer because I'm going to plug it in here, and that is the way I'm going to find my remainder R, as just the difference of what I have divided and what I divide by. And now I know the quotient, which is just 2. So the rest is arithmetic and complex numbers in Gaussian numbers, and I still have 1 minus 5i, and then I have with negative 2 minus 6i, and then simplifying I just have negative 1, and then I have negative 5 and positive 6 on top, so that will be just positive copy of I, one copy of I. Just to check that everything is in order, let's just compute the norm, the squared distance of R, and that is just the sum of squares, which is 2. And let's compare it with the norm of what we divided by, so 1 minus 3i, and we computed it already, it is 10. Obviously, the norm of the remainder is smaller. So we can be sure that we have the statement of Euclid's division. And in terms of the greatest common divisor computation, greatest common divisor of the pair is the same as the greatest common divisor of the remainder instead of the first, which is negative 1 plus I, and the second. And as usual, we can proceed. So now this is larger than that. This is the verification of that. Now we can proceed with dividing 1 minus 3i by negative 1 plus I with its remainder. I'll call it still a cute twiddle, and then, sorry, with its quotient and its remainder. So the second computation will be computing these two Gaussian integers. And the same trick, we start with this number, we divide by this in Gaussian numbers, and we can choose the closest. So when we do the computation, we do the same trick, we multiply by the conjugate of the denominator. It could have been simplified with respect to minus signs, but I'm not sure if it was doing. So just taking the denominator and conjugating and putting it upstairs and downstairs, and then downstairs we have 2. And upstairs we have to compute what we have. So negative 1 from this product, and then negative 3 and another negative sign will give us positive 3, but I squared will give us negative, so that will be still negative 3. So negative 1 and negative 3 will be negative 4. And then for the imaginary part we have negative 3 with negative 1 giving us positive 3, and negative I with 1 giving us negative 1 copy of I, so that will be negative 2 copies of I altogether. And that is, yeah, am I doing it right? So now it will be positive 3 here, on the negative, so it will be positive 2 copies of 3, right? Because negative and negative gives me positive 3 copies of I, and on top of that have one negative copy of I. So that is just a Gaussian integer. It's not with rational coefficients. Well, it is, but they're special, they are integer. So we have negative 2 plus just 1 copy of I. So this time the division is neat. We divide in neatly without any remainder. So that is our Q twiddle, and our twiddle is 0. So this greatest common divisor can be simplified further into 0 remainder instead of this. And that means that the greatest common divisor is just this number. It's just this. Because the greatest common divisor of this pair is just that number. And so it's the same as for this pair and for this pair. So we have computed it. And the answer, of course, is, so we can write it again as the final answer. The answer is negative 1 plus I as we obtained it. But any divisor is defined up to an invertible multiple. So it could be plus or minus 1. So that plus is just given the same. Minus 1 multiple of that will give us 1 minus I. So that is an alternative way of writing our answer. Well, alternative. There are 4 possibilities, so it's incorrect to call it an alternative. One of the answers, and then the other 2 are when we multiply by I or by negative I. So when we multiply by I, we'll have negative I, and we'll have negative 1 instead of positive I, so we'll have this answer. And when we multiply by negative I, we will have just the negative of that, so we'll have that answer. So when you record your answer, yeah, you can freely choose between the 4 possibilities. So try to choose the simplest. That would be the simplest of the 4 for me. So I'll just lock my final answer to be this. That is it for this little computation. See you later.